Hi guys, it's Mrs. Millicent. Okay, we're going to look at recursive binary search code. Okay, so what we're going to do is we're going to talk about the code and then we're going to trace it. Okay, so what's a recursive binary search? We know what a binary search is. It's when it takes, when the code takes a list or an array and it cuts it in half. Okay, binary cuts it in half and it checks to see if the value you're looking for is in the first half or the second half. So if it's in the first half, it ignores the second half and then it takes the first half and cuts it in half. Okay, and again, is it less or is it more? So it keeps cutting your list in half and half and half. So every single turn, it can get rid of half the list. So it's pretty efficient. Okay, so we looked at it from a non-recursive standpoint. Now we're going to look at it recursively. Okay, so what does our binary search do? Again, it's going to take the array, it's going to find the left and right indexes, okay, and of course this is what we're searching for. And it's going to go through and it's going to look at all these indexes, okay? So if the left is greater than the right, then we know the item can't be in there, and that'll come at the end if the item's in there. So here's the important part. We want to be able to trace this code and find all the middle values, okay? So when we find the middle values, that's when we're finding, where to cut the array in half so we can get rid of one of the halves, okay? So once we find that middle value, we look at the middle index value. We look at the value in the array that matches that, okay? That corresponds with that. And if it equals what we're looking for, we're done. So then we return the index of the item that we were looking for. If that middle value is greater, then we're going to go to the left side, okay? And then else we're going to go towards the right side, okay? All right, so let's trace through one of these. So I have a small little array here. Let me put my index numbers. Okay, so my directions say for each state, what is the result? Okay, so we already know what the result's going to be. And find all the mid values and how many times the binary search method is called. Okay, so it's first called originally once, but then how many additional times is it called? Here is where we have our recursion. Okay, so we're going to have it called at least once. So I want to know how many more times it'll call, okay, or total call. Well, we already know the output. If it's searching for 4, it's going to output with a 0, okay, because that's the index where 4 is. So we already know our output. All right, so let's go through so we can figure out each of the mid values and watch how it chops this array in half, and we'll figure out how many times our binary search is recursed. Okay, all right, so let's start. Array 3, 0, length is 5 minus 1, which is 4. So remember, this is left. Oh, that's not left. This is left, and this is right. Okay. Left is not greater than right. Okay. So now we're going to have to calculate our mid value. Okay. Middle, mid, whatever. So left plus right. So 0 plus 4 divided by 2. That's 2. Okay. So we'll look at x. We're searching for 4. Is 4, is it equal to the value at index 2? No. Okay. It's not equal. Is it less? Okay, so 4 is less than the value at index 2, okay? So now I can do this one. So now I'm going to do binary search, same array, I'm not going to put that down. Now the left is still the same, so it's still going to be 0. Now my right is going to change to mid plus 1. So now I'm just going to look at mid minus 1. I'm thinking mid plus 1. Did I say mid plus 1? I'm like, that's not 3. Mid minus 1. That would be 1. What am I thinking? And of course, we're still looking for 4. Sorry about that. I said plus when I meant minus. Okay. So now we got to recurse this one. So here's our new left and right. So let's find the mid. And of course, I'm sorry. Left is not greater than right. So we're going to keep going. So we'll find our mid equals. So now we're going to do 0 plus 1 divided by 2. Well, 1 divided by 2 is going to be a half. Well, this is, these are integers. It's not going to give us a decimal, so we're going to end up with 0. Okay, so let's see. 4, now if I go to index 0, is equal to 4. Okay, so I'm done. So it equaled 4, so now I'm just going to return my mid, which is 0. So I knew I was going to get that. Okay, so this one, it only went through the binary search 2 times. Okay, so the method was called 2 times. Okay, that was pretty quick. Let's do this one. So this one, I'm going to search the same array for number 17. Well, we know 17 is not in there. Okay, so if it doesn't find it, it's going to return a -1. Let me fold this up so I can, let's see that other one. I still want to see my array and my code. Okay. Oh, good. So my left and my right. My right, again, is still 4. Okay. So I know this one isn't here. So how many recursions am I going to have to do until I finally get a left value greater than a right value where it's going to return the -1? And of course, I want to record my mid values all along the way. Okay. So the first mid value is the same as the other one. So it's just 0 plus 4 divided by 2, which is 2. So now I'm going to take 17, which is what I'm looking for, and compare it to the item at index 2, which is 21. Okay, well, it's less. Okay, it's not equal, it's less, so I'm going to do this one. So binary search. So again, same array. My left is still 0, and now my right is going to be mid -1, so I'm going to do 1. Okay. Oh, and I forgot to put in the 17 that I'm looking for. Sorry about that. So now I'll find the middle of 0 and 1, which again is 0. Okay. So I'm going to take 17 and I'm going to compare it to 4, which is the item at index 0, and that is greater. So it's not equal, it's not less, it's else. So now I got to do this one. So same array, mid plus 1, so 0 plus 1 is 1. I'm going to use the same right, which was 1. Okay, and of course I'm looking for 17. So now let's do this one. So the middle value, 1 plus 1 divided by 2 is 1. Okay, so I'm going to take 17, I'm going to compare it to the value at index 1, which is 16. And it is greater. Okay, so it's not equal, it's not less, it's greater, so I got to do this one. So now I'm going to do binary search, same array, mid plus 1, so I'm going to do 2. The right is still the 1, and of course I'm looking for the 17. So now before I do my mid again, now I've hit where left is now greater than right. Okay, all these other ones, left was less than right. So now, since 2 is greater than 1, I'm going to return my -1, which means the item was not in the array. And I knew I was going to get that. Okay, so again, it's nice you're going to be asked to either state a mid value, okay, or how many times the binary search ran. So 1, 2, 3, 4. The method was called 4 times. Okay, so those are the types of questions you're going to see on your recursive binary search. Let me just highlight those with the, I'll do green. Okay, so again, output, you know what output is without even tracing the code. So you want to know your mids, okay, you want to know your mid values and how many times the method is called. Okay, you have 2 here. You want to know these mid values and then how many times the method is called. Okay, all right, I think I gave you a couple to do for practice, so I hope that this was helpful in trying to take out some of the key parts of a recursive binary search. Okay, I'll see you next time.